This video is the second part or the sequel to the virtual override video, where I explain the virtual and override keywords. If you haven't watched that video yet, I strongly encourage you to watch it before this one. It'll make a lot more sense because the topic in this video builds off of the topic in that video. So I'll link it in the description. Please take a look if you haven't already. Anyways, um, before I do the coding, like usual, I'll do a quick conceptual explanation. I'm just switching to this tab, but I'm not actually going to draw anything. I think the explanation that you're given in the slides is really good, where it poses a hypothetical program. I believe it's some sort of gradebook program where there's two types of people. There's students and teachers. So those are your classes, and they both inherit from a person abstract base class. Now, an abstract base class is nothing but a base class that is intentionally designed not to be initialized on its own. So if we were to have, our person base class, then our student derived class, and our teacher derived class that both derive from person. If we wanted to initialize these in main, initializing this would be fine, initializing this would be fine, but if we wanted to initialize person, that would throw a compiler error because it's an abstract base class, which is explicitly designed to not be initialized. And the point of an ABC, or abstract base class, the common terminology is ABC, is just to be a starting point for, I guess, the, quote unquote, real classes that you actually want to use. So in the case of the example from the slides, the real classes are, student or teacher, but they both inherit from person. So that way they don't have to like write duplicate code for stuff like name or age or whatever. Um, so going to the coding example, first things first is I'm just going to include IOStream because we're going to be doing some printing using namespace std. And then we're going to create our int main. I always do that, int main, for actual testing. So I think in the other videos I've been using letters and stuff, but for this one I'm not going to use letters. I'm going to use like concepts to make it a little more digestible. So our abstract base class is going to be animal. And this animal class will have a I'm trying to think of what the function should be. I'm gonna go with feed. I believe in class I had two functions. I had a move function and a feed function, but I think the move function isn't really critical to demonstrating the concept and just made it more confusing. So I'm gonna stick to only one function. Now, an abstract base class, in order to tell your program, hey, this class is an abstract base class, you need the following syntax. So our function is going to be called feed. But the first step is to declare it as virtual. And then the second step is to do equals 0. And this tells our program that this is a pure virtual function. In order for a class to be considered an abstract base class, it has to have at least one pure virtual function. Now, what you decide to make your pure virtual function doesn't matter. It could be, we only have one function, so it's pretty obvious. It's going to be this one. But if you had, I don't know, let's say virtual void move, this could be your abstract, your pure virtual function, and then you could write some implementation here, whatever. For the example, we're only having one function, virtual void feed. And like I mentioned in the virtual override video, for any base class that uses virtual, you have to include a virtual destructor. So we're going to do virtual animal, and then empty implementation. So this is our abstract base class. So now let's create a class that inherits from it called class llama public animal. So now we can go ahead and override feed. So again, if you watch the video on virtual and override, this should be just kind of a recap. And feed is just gonna print out delicious grass. I don't know, llamas eat. I think they eat grass. Um, and yeah, Loki, that's all there is to it. So if we wanted to initialize llama, we can just, or sorry, instantiate llama. We can just do that. Um, and that's totally fine. Like our program will compile and run. Nothing outputs because I didn't print anything. But on the other hand, if we wanted to instantiate a class of type animal, like animal, you'll note this red squiggly line indicates that class animal is abstract. It's an ABC because feed is a pure virtual function because we define it as virtual equals 0. So now if we were to actually try to run this, we get an error because it's an abstract base class. So that's all there is to it. Originally, this demo was longer, but because I split virtual override into its own video, this demo is a lot shorter. So it feels a bit too short, so I'm just going to go ahead and recap what the point of an abstract base class is. So the point is that this serves as a starting point to our real classes, Solana. So if we wanted to make like another class called class frog, public animal, we could still do that. But um so yeah, that's all there is to it. If you have any questions, review the slides. Um, feel free to DM me. Check the Codio materials like always. And good luck with Lab 6.